Hello, my dear friends. I am Dr. D.T. Sawant from J.A.T Arts, Science and Commerce College for Malegaon Dist-Nashik. Today, we will discuss on the topic that is a seismic waves. What seismic waves are? Seismic waves are generated by the release of energy during an earthquake. They travel through the earth like waves travel through water. As the surface waves seismic waves passing through the earth are refracted in ways that show distinct discontinuities within Earth's interior and provide the basis of belief that Earth has that number one is a solid inner core, number two is a liquid outer core, number third is a soft asthenosphere, and last one number fourth is a rigid lithosphere. So, as the seismic waves has a behavior of seismic waves in the different layers of the earth, provides the most authentic evidence about the composition and structure of the earth. The different types of waves generated during the occurrence of an earthquake are generally divided into three broad categories. So, as the study which is being related as to the earthquake is called seismology, and which is the branch of geophysics. The location within the earth where the rocks actually break is called the focus of the earthquake, and hence the most foci are located within 65 km of the earth's surface. However, some have been recorded as the depth of 700 km. The location on the earth's surface directly above the focus is called the epicenter. So, as a earthquake focuses which generated on the seismic waves are of two types. Number one is a body wave spread outward from the focus in all direction. Number two is a surface waves spread outward from the epicenter to the earth's surface, similar to ripples on a pond. These waves can move rock particles in a rolling motion that very few structures can withstand. These waves move slower than body waves. As there are two types of body waves. Number one is a primary, and second one that is a secondary wave. While discussing to the primary waves, they are also called as a longitudinal or compressional waves. In this type of wave motion, particles of the medium vibrate along the direction of propagation of the wave. These are the high frequency, short wavelength longitudinal waves. These waves travel not only through the solid part of the earth but also through the liquid part of the core. A primary wave travels with fastest speed through solid material and under certain circumstances. It can change into a secondary wave on refraction or vice versa. In the liquid materials, their speed is slowed down. These waves are analogous to sound waves, wherein particles move both to and fro in the line of propagation of the ray. Much of our knowledge of the internal structure of the earth has been gained from the study of primary and secondary waves. Secondary waves, if you will see that these are also S waves, these are also called as a transfer or distortional waves. Secondary waves are analogous to water ripples or light waves, wherein the particles move a right angle to the rays. A secondary waves cannot pass through liquid materials. These are the high frequency, short wavelength waves which are propagated in all directions from the focus and travel at varying velocities, means the proportional to density, through the solid part of the earth crust, mantle and core. As a surface waves, when we are discussing that they are also called as a long period waves. These waves generally affect the surface of the earth only and die out at smaller depth. The surface waves are characterized with low frequency, long wavelength, transverse vibrations which develop in the immediate neighborhood of the epicenter. The surface waves are responsible for most of the destructive force of earthquakes. They are confined to the outer skin of the crust. They cover the longest distance of all the seismic waves. When an earthquake occurs, the seismic waves are recorded at the epicenter with the help of the seismograph. In the beginning, a few small and weak swings are recorded. Such tremors are called as the first preliminary tremors. After a brief the interval, the second preliminary tremors are recorded, and finally the main tremors of strong waves are recorded. As the seismic waves passing through the earth, means from in the interior of the earth, are refracted in ways that show distinct discontinuities within Earth's interior and provide the basis for the belief that Earth has. So, first one, that is a solid inner core. Second one, that is a liquid outer core. And third one, that is a soft asthenosphere, and fourth one is a rigid lithosphere. So, as stated above, the seismic waves are similar in many respects to light waves, and their paths are governed by laws similar to those of optics. Both seismic vibrations and light vibrations move in a straight line through a homogeneous body. If they encounter a boundary between different substances, however, they are reflected or refracted. Familiar examples are light waves reflected from a mirror or refracted as they pass from air to water. So, as a branch of geology called seismology lets us obtain information about the interior of the earth without directly observing it, seismologists apply principles and laws of physics to study the internal structure of the earth. So, geophysics includes the study of seismic waves and the earth's magnetic and gravity fields and heat flow. Because we cannot directly observe the earth's interior, geophysical methods allow us to investigate the interior of the earth by making measurements at the surface. Without studying these things, we would know nothing of the earth's internal structure. And hence, the keeping in mind that seismic waves have similar properties to other types of waves. For example, those are light waves. The wave properties of reflection and refraction are useful for learning about the Earth's interior. So, it results of early studies shows that the internal structure of the Earth consists of distinct layers. Seismic reflection, those are seismic waves bounce of rock boundaries of different rock types, and their travel times are recorded on seismograph. The seismograph records the time of rock for the waves so that it travel to the boundary, reflect of it and return to the surface. So seismologists can measure the time this takes and calculate the depth of the boundary. As a seismic refractions, wave changes velocities and directions when they enter medium of different density than the one they just passed through. So there are some layers. One is a low velocity layer, and second one, that is a high velocity layer. Low velocity layer, these layers which are seismic wave travel slow. For example, granite. Secondly, that is a high velocity layer, which is a seismic wave travels very fast, and hence the example which is given, that is a gabbro. Research from seismic reflection and refraction. So number one, there are three main layers of the earth: crust, mantle and core. Secondly, if you see that the continental crust is thicker than oceanic crust, and seismic waves travel slower in the continental crust, meaning that they are made up of different kinds of rocks. Means, for example, are a granite and basalt. Number third, there is a distinct boundary between the crust and the mantle called the Morovicic discontinuity, and simply the Moho. Number four, there is a layer within the mantles up to 70 km thick beneath the ocean and up to 250 km thick beneath the continents, where waves travel slower than in more shallow layers. This layer is called the low velocity zone, and scientists have concluded that this zone is at least partially liquid. In plate tectonic theory, it is also called as the asthenosphere, which is the semi-molten region of the Earth's interior just below the Earth's rigid crust that allows for tectonic plate movement. And last, fifth is a primary waves can pass through the outer core, but secondary waves cannot. So in the early 1900, scientists discovered that part of the Earth's surface did not receive earthquake waves. So scientists found the direct primary waves disappear from seismograph in a region between 104 and 140 degrees away from an epicenter. The seismic waves are bent or refracted upon encountering the core mantle boundaries, casting a shadow called the primary waves shadow zone. Secondly, that direct secondary waves are not recorded in the entire region more than 104 degrees away from an epicenter, and this is referred to as the secondary wave shadow zone. The secondary wave shadow zone, together with the knowledge that liquids do not transmit S waves, is evident that the outer core is liquid or behaves as liquid. Hence, the secondary waves cannot travel through the liquid because they are shear waves which attempt to change the shape of what they pass through. Simply put, a liquid doesn't care what shape it's in. For example, you can empty a bottle of a water into an empty box and it will change the shape with the shape of container, and hence the liquid cannot support shear stresses, so shearing has no effect on them. Therefore, a liquid will not propagate shear waves. So here we will conclude our lecture. Thank you very much.